different tubes connect, and we can just cycle through. So you switch, wait until it gathered enough data, write the data down, switch, etc. So what we're doing right now is we're setting up this test to look at what the pressure differences are across. We can't turn it on right now, so I'm going to kind of summarize what we're going to do, and then we can decide if we want to take a break or something. But we'll check the pressure differences. So we have a way of translating from the wind speeds that airspeeds that we're measuring inside this model to an actual airspeed on the actual site. The goal of that is to see where we are in terms of the 10 air changes per hour. Because we've got a fixed volume of Clasroom, we have a fixed cross-sectional area of that duct, and so if we take that speed, we know exactly what the volumetric flow is, we can figure out what the air change rate is. So what we'll do is we'll take those pressure differences, and then we get to start kind of playing and seeing what, well, first of all, seeing where we are in terms of the existing condition, which I've done, but I haven't done the exploration of iterations. And my sense is that we're kind of right near a critical level where we really need to figure out what the most important design aspect is. And so if we can identify that, then we know what to pay attention to. And so what the options that we'll do is we'll try, this is a stiff spring. We'll try different variations. We can, this is 2 sets of louvers on a window box. And these are removable, so we can just try doing what the acoustical engineer will probably want to do, which is to cover it all up, to see what happens. We can try taking it off as well to see if that increases flow.
We need to find out where the choke point is.
Yeah.
Okay. And if we need more air, what we can do to increase the choke point. So right now you won't see any windows, you don't see any, any of the parts of a normal building. So this is not a really good model for showing decline.
Yeah. Yeah, for instance, there's no opacity, or there's opacity there, and transparency there.
I saw you talking about daylight, No, I mean, where's the daylight?
Well, now that we have our wind hat on, we don't care about daylight.
Yeah, we don't care. So we can also, these are the louvers on the end of the duct, so we can also try taking that off and seeing what happens without this louver.
So Ben, these are designed to mimic the wind flow of a normal of the louvers that have been specified.
Okay.
But notice that there are only 2 louvers,
right?
And that's because the critical dimension is 1/8 of an inch. So they have the same opaqueness, but they have fewer veins. So that they scale appropriately to what's going on here, as opposed to what it looks like. Because if we put the actual to scale, no wind would go through.
Right,
yeah.
Right. Oh, I see. Yeah, that makes sense.
So then, let's see. So any questions on this? Or, thoughts about what else we want to check out? Well, the other thing we'll want to do with this is we have a plexiglass side of this model. We're going to try some visualizations with this, and so where we'll actually be able to see, the air velocity is going to give us an air change rate, but we don't necessarily know, does that mean the air is cycling through evenly, or is it more on one side or the other? So the visualizations should help us look at distribution of air in the room.
Good.
Yeah, it could just be, you could have the fans will.
The fans will help.
The ceiling fans.
Right.
Will help a lot with that.
Okay.
But we can see if it works without ceiling fans. That would be nice to know. So what's the plenum space for?
Oh, that's a good question. I was just talking about the head scratching that Abe and I did, because one of the interesting things is that if you look at the airflow through this space, one opening is the duct, which goes over to here.
Right.
The other opening is the window box, which comes down to here. And so you actually have an inlet and an outlet that are off by one floor.
Kind of simulates the flow.
And so we needed to actually have air flowing up through here. and through those ducts. So if you actually look underneath,
This is great.
you can see that there's this dummy duct that goes all the way across,
Right.
just to equalize the pressure.
That's very good.
Wow, that's
And so then what we did is we took this is what I'm going to show. If you look here, there's a hole right here. So I made a hole here and a hole here to check the wind speed through the window box. And I started with an opaque.
Oh, and you just drill holes in it.
And I drilled holes to get it so that the airflow
Was the same.
through here matched with each. So I started out with too many holes, that's why I taped over. those two.
I was gonna say, what do? You make one hole at a time and just kind of take.
Yeah, I
some,
just went, I was
readings?
like, oh, I'll make a bunch of holes, and I realized, oh, actually,
well, we need
that
to-
was too many.
Too many holes. Okay.
So the magic number was 5. Which actually surprised me, because I figured I would need more opening. But
Yeah. Well, it's the fact that you don't have any obstructions in the middle. means
Yeah.
that,
Actually, in reality, the duct went over.
say it again?
There's a beam.
We modeled
Okay.
just to the ceiling
Oh,
and
okay.
not to the floor.
Oh,
So
okay.
all the structure is happening above.
Yeah, above it. Okay, well.
Oh, in terms of another, or above.
Yeah, this-
like there's a plenum.
This plane is the actual ceiling of the space, and
Yep.
the plenum and the floor and all the
Yeah.
structure is not modeled.
Oh, okay.
Yes, the only thing that actually, the only reason why this is here is just to connect this with that window box so that there would be airflow through there. That's
So you're
the
not
only
doing floor to floor. Okay.
floor to ceiling.
Floor to
yeah.
ceiling. Okay.
Because some of the pressure buildup on this area is going to feed a couple things. It's going to feed up into the window box and through the ducts. And if we didn't have this, then we'd be over exaggerating the airflow through the duct.
Yeah, it would either be, you'd either have, if this were solid under here, it would be overestimating how much airflow would go through the duct. If this had a hole and this weren't here at all, it would probably send too much air up through there.
So the model's actually from, like you said, floor to ceiling.
Yes.
Okay.
Yep.
With a dummy, kind of a dummy.
Yeah, so the space of interest is actually between here and here.
Right.
Everything outside of that is just for the sake of accurate measurement.
Okay. Okay, I see that. Okay.
And of course, the facade geometry is accurate as well.
Is that what we did?
I think so.
No, no.
What are you thinking, Masato?
I think that's correct, Masato. Because the acoustical chamber is the inlet for the closed classroom. And the exhaust is up on the top, right? And the reversed, the high intake and low exhaust on the opposite side.
No, I'm talking about, it's actually, this is not perfectly horizontal.
You mean the duct system rise and
Yeah.
falls?
Yeah, duct system lies,
It pinches.
yeah.
Is the height change as it moves?
Yeah.
How does it change?
Even though it moves up and down, does the height within the duct remain the same, or does it change?